Hello, EVA chemistry students. You should be viewing this on Wednesday, March 25th, and I'm excited to keep on talking about things in section 10.1. We're calling this 10.1b because it should be the remainder of the content in that section. And before we get into the content, I want to remind you to please reach out if you have any questions. Here's my email address. I have official office hours from 9:30 to 11:30, Monday through Friday, and you can still email me at other times if you are working on something outside of those hours and you have a question, and I will try to get back with you for sure. Okay, so before we get into the new content for today, I want to go back to talking about solids a little bit from the previous video. I talked a lot about how solids were locked into fixed positions. They have a definite shape. They have a definite volume, and they're going to pretty much stay put, and that's because they're organized in crystal lattices. And so a crystal lattice is a definite, nice, clean, 3D predictable structure that you can count on for a solid to have. And it consists of the particles. I'm going to show you in your textbook here. It consists of the particles themselves, and they're locked in their shape, their crystal structure, by covalent bonds or ionic bonds or metallic bonds. And so we're not going to get back into the bonds right now, but we've already covered those this year. But it's because of those bonds that they're going to stay where they are, and they're going to be very secure and predictable. The only way they're going to come out of that is if they receive too much energy, that they kind of vibrate way out of their positions and then they melt. And so that crystal lattice will stay intact as long as the particles just kind of are able to vibrate back and forth and they don't get too much energy. The more heat is applied or any other kind of energy like that, it can make them break out of those bonds. And so I just wanted to make sure I cover that and mention the term crystal lattice so that you understand that that is a big part of what makes a solid a solid. Now we're going to talk about a couple of other types of things that don't really fit neatly into solid, liquid, gas, or plasma. Okay, one of those is liquid crystals. Liquid crystals are kind of like liquids, as the name implies. However, instead of just flowing freely all the time and having a little bit of attraction for each other, they actually will retain their crystal-like shape in one or two dimensions, especially if electricity is involved. Okay, so we use this to our advantage. We've been able to harness this, and we use it in stopwatch displays. Okay, so you can see the nice digital numbers there, and this has to have batteries because the electrodes will light up differently depending on what's going on. Like obviously this has a counter for time and it's displaying it, and it's constantly, the screen is constantly changing, okay, as the electrodes change. And so it happens very quickly. And then we also use that in our calculators. So as I'm typing in numbers, okay, the liquid crystal display, it's called an LCD as well, is responding to what I'm typing in. And so whenever you hear the term LCD, it stands for liquid crystal display. And I've already mentioned that we use that in stopwatches, calculators. We also use it in really, really old computers. Like most computers nowadays are not LCD. We've gone way beyond that technology. You might think of a pager, okay, if anybody has ever seen one of those. Hopefully you're not using that, because mostly drug dealers use that, and you are not a drug dealer. Don't be a drug dealer. And also, a really old Game Boy, like one that was black and white, like maybe first generation Game Boy, that would have an LCD as well, liquid crystal display. So liquid crystals are cool. Another really neat kind of matter is an amorphous solid. And as the name implies, it's kind of like a solid, but it lacks a really nice crystal lattice. It does not have a good, clean crystal structure. Instead, it's got a really haphazard, disjointed, and incomplete crystal lattice. Okay, so it's not going to be nice and clean. And you have these in your home. You've got peanut butter. You probably have some butter in the refrigerator, that, especially if you take it out of the refrigerator and let it warm up to room temperature, it's very pliable. Silly putty, Play-Doh, cotton candy, wax, especially if it's a little warm, it's easily pliable. Another one is glass. Glass seems like it's more a true solid because it breaks so easily and it seems really firm. Okay, but if you really look at it, glass is like a lot of long particles that are just kind of like tangled together. And the only reason it's frozen in place is because they're tangled. It's not that it has this really nice, neat crystal display. And so glass is another one that definitely is an amorphous solid. So we've covered liquid crystal, not liquid, well, that too, but we covered what a crystal lattice is. That's when you have a true solid. It's a very orderly display or very orderly arrangement of the particles, and they're gonna just stay locked in those fixed positions, but they can vibrate. And then we talked about liquid crystals, which are like liquids, but they can flow and they'll respond to electricity and like crystallize up when they're exposed to electricity in certain dimensions. And then amorphous solids, a lot of textbooks call these amorphous materials because they don't even want to go there with the word solid, but your book still uses the word solid for these. And amorphous means without shape. And so there are things that are very flat, pliable. You can move them around, mold them, change their shape, like Play-Doh, things like that. And they're not going to have a really nice, good crystal lattice. And then finally, I wanted to say a few more words about plasma, because this is at the end of the section in your book. Plasma is the least common state of matter that occurs naturally here on Earth. We see it in lightning and then in man-made things like fluorescent lights and also neon lights when they're turned on. When they're off, not plasma, it's just gas. Typically noble gases or a mixture of different types of naturally occurring gases. But when electricity is turned on, what happens is the gases get stripped of their electrons, and it's really high energy. So it's higher energy than a normal gas would be at that point because they're flying all around. You've got all these positive and negative charges, but they're going so fast that they can't attract each other, and it's crazy. Very high temperature, very high energy. That's why we need protective coverings on fluorescent lights, especially in classrooms and homes. But the good news is if the bulb does bust, it cools off very, very, very quickly. So that's good news. And then, of course, we see plasma in our sun and other stars. I mentioned that plasma is the least common naturally occurring state of matter on the Earth, but it's the most common state of matter in the universe because of all the stars being made up of plasma. So remember, the sun and other stars are not burning. They're not on fire. There's no oxygen in space, so they cannot burn. Okay, but what is happening is a bunch of hydrogen atoms are combining to form helium. That's called nuclear fusion, and it's creating a lot of energy, giving off a lot of heat, a lot of light, other forms of energy as well. And that's what plasma does. Like, it's going to continue to burn that, or to not burn. It's going to continue to fuse those hydrogen atoms in the sun and other stars until they run out, because stars can actually die. So once they run out of enough hydrogen to keep the process going, they're going to either explode or implode, depending on the size of the star, and go into something other than a star. It might be a supernova or something like that. Okay, so I think we've covered all the stuff. Remember, if you have any questions or concerns, okay, here is my email address again. Also, make sure that after viewing this video, you complete the form. There's a Google form that you need to fill out, and that counts for your attendance, and it's also graded. It's going to be recorded as a classwork/homework grade, so just like an assignment grade. So thanks for listening, and I hope you're doing well.